Hello, in this video we will deal with the Nobel in chemistry for the year 1911, awarded to Marie Curie née Sklodowska for the discovery of the elements radium and polonium by the isolation of radium and the study of the nature and compounds of this remarkable element. Here you can see the element radium, and it is found in ore like this, which is called pitchblende, and the same for polonium, which is also found mainly in pitchblende. Then we deal with the Nobel Prize lecture, Radium and the New Concept in Chemistry. This time she gave one in 1903, she did not. Becquerel discovered radioactivity some 15 years ago. The study led us key to the discovery of new elements. Particularly radium was intensely studied. A new science was developing. Many scientists devoted themselves to studying radioactivity. One of them was Rutherford, Nobel Prize 1908. Now the field, though connected to physics and chemistry, is well defined. The element radium was the one that proved that my thesis that radioactivity is an atomic property that proves this. Yeah, we can now predict the existence of at least 30 more new elements. We also shown that many of these elements will be atomic transformations, like was the case with helium. The task of isolating radium is the cornerstone of this new science. The rest of the lecture will be about radium. Becquerel, Pierre Curie and Rutherford have described many radioactive phenomena in their lectures. The discoveries of radium and polonium were done by Pierre Curie and me together. One of the properties of radioactive elements is the ionization of the air around them. This ionization is called by the rays emitted by the uranium compound. The activity of uranium and thorium compounds is atomic. The activity of a compound is only due to the metal contained in it. At first it seemed that all active minerals contained uranium or thorium, but pitchblende, chalcolite and austenite had a greater activity than might be expected on the basis of the uranium and thorium content. The minerals were more active than the pure metal. When artificially making chalcolite from pure product, it was less active. Then I thought that the natural minerals might contain another highly active material, not being thorium or uranium. I tried to isolate the substance by chemical analysis. It took several years to prove that pitchblende contained a new and highly radioactive element. We created a new method of searching for these elements based on radioactivity. After each separation, the activity is measured. This method was later come into general application. Using this method, we found two new elements: polonium, accompanying bismuth, and radium paired with barium. Other radioactive elements have been discovered: actinium by Bernier, radiothorium and mesothorium by Hahn, ionium by Boltwood, etc. From a chemical point of view, our substances appear to be pure bismuth or barium. It had to be shown that they contained another element. Radium had been isolated, it took years. It is now industrially manufactured. No other radioactive element is. Elements containing radium are investigated by electromagnetic methods and with photographic plates. The best mineral is the Sint-Joachimstaal pitchblende. We found that only decigrams of radium per ton of mineral. About 10 to 20 kilos of barium sulfate can be extracted from 1 ton of the mineral, but even this sulfate is 30 to 60 more active than that of uranium. The sulfates are purified and converted into chlorides. To separate radium from the barium, I used the method of fractional crystallization of chloride or the rhodium. The radium becomes concentrated in the crystals. This process takes a long time. Progress is monitored through activity measurements. Mackay saw a new line in the spectrum of chloride enriched by crystallizations, which he attributed to a new element. I determined the atomic weight of the new element in the salt. The method used determined the chlorine content in a known amount, L-hydrous chloride. A fast balance is needed to avoid absorption of water during the weighing. In the end of 1997, I came to an atomic weight between 226.31 and 226.62. It has now been proven that radium is a new element. It is the higher homologue of barium in alkaline earth family. Z is 58 for barium and 88 for radium. That's the number of protons in the nucleus. It's on the same row in the periodic table as uranium and thorium. Chemically, radium is very much like barium. Their salts are isomorphic. Due to the radioactivity, radium salts are spontaneously luminous. Radium itself gives 180 kilograms power per gram of radium per hour. In 1910, Curie and Adibiene isolated radium in its metallic state. This was done by distillation on the hydrogen of a chloride solution using mercury cathode. It was a difficult process. The metal is very unstable. The metal itself is just as radioactive as predicted. This was important in convincing opponents of the atomic hypothesis of radioactivity. The case is different with polonium. It's about 5,000 times less present in minerals than radium. Many efforts have been done to isolate the polonium. The difficulties are heightened because polonium disintegrates spontaneously. Its half-time is only 140 days, while radium is 2,000 years, which is much more stable. There's little hope to determine polonium's atomic weight, but we may observe its spectrum. With Debienne, I took efforts to prepare polonium from uranium minerals. It yielded a few milligrams of a substance 50 times more active than radium. We were able to observe its spectrum, which contains new lines. Now the theory about the atomic radioactive formations. What is the source or energy involved in radioactivity? The energy comes manifest by emission of rays, which produces thermal, electrical, and light phenomena. The emissions are spontaneous without any known cause. A hypothesis is that the emissions are in fact matter, which would result in a lessening of weight of the active substance. A series of experiments have shown that this idea is probably correct. The radiation is not permanent but disappears in time. It is observed that in some cases radioactivity increases in time. It's probably the case that new radioactive materials is created during periods with rising activity. It may be assumed that every radioactive substance undergoes a transformation. This is in fact a summary of the work of Rutherford and Soddy, theory of atomic disintegration. Radioactive substances undergo a series of atomic transformations, giving birth to a new atom with a smaller weight until a stable state is found, a non-radioactive substance. Brilliant in this theory is that helium is always present in radioactive materials. When radium disintegrates, the helium is emitted as alpha rays. That this happens is proved in experiments by Ramsay and Soddy. The alpha particles are also found as helium gas. Thus radium can be seen as a molecular combination of helium with other elements. This is the third clear example of atomic transmutation. Theoretical work on radioactive transformation is now 30. I think that this meant that 30 new elements are found being envisaged in 4 series, classified in 4 series. The primary substance of this series are uranium, radium, thorium, and actinium. The first 2 can be combined. Polonium is part of the radium series. The actinium series is related to the radium series. By the way, now we know, this is centered by me, that there are 4 decay chains: thorium, uranium, neptunium, actinium. We will see them shortly. According to Rutherford, the radium series will end with lead. In the meantime, polonium is now studied. Debierne has proved that polonium produces helium. There are several experiments to determine polonium's atomic weight, which all point to the same number. Z is 209, A is 84. Recent investigations show that potassium and rubidium emit a very feeble radiation, similar to beta radiation of uranium and radium. It is not known whether or not they are true radioactive bodies. The electric method allows us to detect the presence of 10 to the power minus 10 grams of radium in a few grams of material. Without the discovery of radium would not have been possible. The same is true for the traces of radium, which can be detected even by they are only 10 to the minus power cubic millimeter. This is small, of course. In the new chemistry, the electrometer, not the balance, is the current tool. And another remark by me, the device was invented by Curie and brother Jacques Curie. Well, this is a summary of the lecture. If you want to read the complete lecture, you can follow this link, which will also be in the description under the video. This is, of course, a summary made by me. This you have already seen. Here you see the electrometer we will talk about, invented by Pierre Curie and I think also his brother, and was used, of course, in the investigations by the Curies. And here you see the 2 of the 4 a chain reaction series. This one begins with thorium and it ends here with lead. And the neptunium series begins here with neptunium and ends with this is thallium. And there are two more here. You have the uranium ending also in another form of lead. And the actinium series is this one. Does not begin with actinium but with uranium, but actinium is in it. This one is called uranium series. That's why this is called actinium series. And it ends. It is still another isotope of lead. And in the days of the Curies, only 3 of these were known, as we have seen. One was discovered later. Well, this was it for the moment. Next week we will, of course, go further with the Nobel Prize in Chemistry. That year will be 1912. You can imagine that. For now, thank you for watching and maybe till another time.